I will start. So first of all, I will start with introduction to introduce myself. My name is Victor. I work in data branch Eindhoven office. I'm a field application engineer, so I support PLCs, HMI, inverter, and a lot of products, controls. So I'll be taking us through the training section today. And the session today is quite practical and very interesting. When you have questions during the section, so do not hesitate to ask your question. And we're also privileged to have my colleague here, Johan. So we'll be anchoring this session as well. You're welcome, Johan. So during the questions and answer section, it will be a very resourceful personnel for us as well. So when you have any question, don't hesitate to ask. So today we are looking at a very interesting, friendly, special function we have in our ASPLC, and that is CANopen special mode. So this CANopen special mode is a feature that we have to help you easily control your Servodrive and inverter using CANopen. So if you're not an expert in CANopen communication protocol, using this function that we have in this ASPLC, you can easily control your drive, your inverters using CANopen communication. And also our ASPLC is a perfect choice when it comes to machine automation. So for your machine automation need, and also of your customer, AS series PLC is the best choice you can make. And we have different series in this PLC model. We have AS300. I think this is the picture you could see on the screen. And this one, you can use the CANopen, you insert the CANopen communication card on slot 2. And we also have AS200. It looks quite alike. And CANopen communication protocol is built, the port, the Internet, the CAN port is built in the AS200 and also AS100 as well. So AS100 is not yet released, but is in production. So as sooner than later, AS100 will also be available as well. So the system configuration. Let's look at the system configuration. So like I told you that AS PLC is a perfect choice for system, for machine automation. So when it comes to AS PLC, you can realize your motion need using that pulse train. I suppose you can see my pointer. I'm using a USB pointer. Hopefully it goes through the Zoom platform. So you can use pulse train to control your drive for the motion application of your need. And also you could also use CANopen as well. When you use CANopen, that you have more flexibility, because CANopen can control more slaves, more drives compared to when you use pulse train. But in this training, we are going to focus on CANopen. So with the CANopen special mode, you can control up to 16 slaves. And to be specific, maximum 8 Sevodrive. Like for example, on this presentation, you can see ASDA A2M. So this CANopen special mode supports our Sevodrive that is compatible with CANopen. So ASDA A2, ASDA B3, ASDA A3, and even the new Sevodrive we are going to have that support CANopen. You can use this special CANopen mode to control maximum 8 Sevodrive. And also in addition, you can control the inverter, maximum 8 CANopen inverter. So in total, you can control 16 slaves using this special CANopen mode that this PLC offers. This is what I already explained in the previous slide. So for I did mention this earlier already as well. For the AS300, to use the CANopen, this is the CANopen card. Hopefully you can see my mouse with a laser pointer. So you install the CANopen card on slot 2. When you have done this, you are ready to go. You are ready to control your drives, the slaves, using the CANopen communication protocol. And for the AS200 and AS100 PLC series, the CANopen port is built underneath the PLC. So if you turn the PLC, you'll see there's a CANopen port is embedded on the PLC itself. So what is the advantage of this special CANopen mode? It makes life so easy for all of us machine maker, because you don't need to do any CANopen configuration. The traditional method of using CANopen to control the slaves, the drive, is to do PDO mapping. You map the address of the slave to the master, the slave you want to control. But with this special CANopen mode, we are going to see shortly, demonstrate shortly, you don't need any special tools to configure the parameter. All you just need to do, once you enable that function, the drive is ready, your PLC is ready to control your slave in a very simple way. Even though you don't even know the techniques, the principle of using CANopen, you can easily control CANopen drives, a CANopen drive, using this special CANopen mode function, communication function in the AS PLC. So let's look at the servo and AC drive configuration. So this session is quite very practical. So we'll not spend much time in theory, like I've been telling you. So we are going to practicalize, and you really see how interesting this feature is. I do believe some of us here, maybe we've already tried this function before. So for you, it's just like a redirection. And for you that have not tried this function before, so it's just an eye opener. So it tells you how easy it is for you to use the CANopen special mode to control your Sevodrive and AC drive. So I will switch my camera, and I will show you the setup of our testing. So you'll see, I hope you can see my camera. I could spotlight it for you to see. Okay, I think maybe it's visible enough. Yeah, so what do we see in this video? So what we are seeing here, this is the configuration I have here. So this is the test setup we are going to use. Let me see if I can, yes, on my side, I've zoomed, it's quite bigger. I hope you can also see it bigger on your side. So what we have here, we have Sevodrive. So the first drive you see here, I'm not sure if you can see my mouse, is Sevodrive. So Sevodrive has that B3. So it has a CANopen port embedded on this Sevodrive. So the Sevodrive is connected to the AS. What you could see there, I'm not sure you see my mouse moving, is the AS PLC. And to be specific, is AS200. So the AS200 is the master. So it's the guy that does the communication, controlling the slave. So the first slave we have is the Sevodrive. You can see this digital display of the Sevodrive. And then the CANopen network is extended to a CANopen communication card inserted in an MS300. So MS300 is an inverter. And then also on the MS300, you can see a tiny cable here, the digital MI3. So there we enable a function called quick stop. We could use that function to quickly disable the inverter in the case of emergency. So this MI3 is connected and shorted. So then the function is enabled. So if it's opened, then this drive inverter should stop for emergency purpose. So this is the architecture: AC PLC, Sevodrive, CANopen slave 1, and the inverter slave 2. And then you can see the motor. So when we begin to control these drives, we are going to see this motor responding to the CANopen command we are going to send to this drive from the PLC using this special fixture. So I hope you can see my slide. So now we are going to start with the setting right away. So now we're going to configure the slaves so that we configure these two slaves. I mean, that's Sevodrive. we configure the PLC, and then we test this function for you to see how easy it is, how it makes making your machine very easy using CANopen communication. So let's start. So first of all, we are going to start with the configuration of the Sevodrive. So what we are going to do, we are going to reset the Sevodrive. To reset the Sevodrive, parameter 02008, we write into it, the drive will be reset. And once that is done, we'll power off the servo, and then we'll power it on again. I will swap my screen. So I will be using TI Designer for this configuration. So for us, this is a very big milestone for us as data. I hope you can see my screen. So for us in data, in the past, we have each product has its own software. But now we are advancing. We are trying to compact our product into one software. So one of the software we have in our GI Studio catalog is GI Designer. So GI Designer can configure Servodrive. So that I don't need to open as that soft theoretically. And it can configure the PLC, the AS200. You can see, hopefully you can see my mouse, AS200. And also Servodrive, I'm using MS300. So from this one software, I can configure all the devices that I have connected in this, setup. So let's start. First, I want to check if my Servodrive is connected to my GI Designer. Then I could, from GI Designer, reset the drive and then power on the drive like we've already seen. So to do that, let me check my communication. If you could also see, this is my device manager of my PC. So in my device manager, I have two COM USB cable connected. COM16 is for my Sevodrive, and COM11 is for my inverter, VFD MS300. So what is going to happen now? I want to check for the Sevodrive if I'm connected. So I expand. So this is an already existing project. Let me click communication settings. So I want to check the connection of my Servodrive with the GI Designer if it's okay. So let me disconnect. So you can see it's COM16. Let me connect. Perfect. You can see that my Servodrive now is connected to my GI Designer. So then this is the parameter settings. To set the parameters, to configure the parameters, this is servo setting. I open it. So once it opens, then I can set the parameter editor. So you can see from the GI Designer, I have launched. Okay, there's a question. Okay, yes, that's a very good question. If we could start it as a new project, what would happen? The differences is not much if we start as a new project. What will happen is that we are going to share this project with you at the end of the training, and you will just follow. So as this is already a pre-made project, it's just for a quick demo of these fixtures, how efficient it is. So the selling point here is that we are trying to tell our partners that to use CANopen with this special mode CANopen ASPLC is very easy. Even though you are a secondary school student and you have not been to university, you don't know what is called CANopen protocol, you don't know what is called ETCAT, you don't know what is called Profinet and those other industrial protocols. If you are taken to a tutorial for just a day, you can use this CANopen to start communicating with CANopen Drive. So the answer to that, pardon me, let's use this for the training. And then we are going to share it with you at the end of the training. And then you can also follow sequentially how we made the project. So that's for that. So what will happen now? Let me go to parameter editor. This parameter editor, I want to read to see if we are connected. So let me read the parameters from the Sevodrive. You can see that I can read. So now I'm reading. So parameter file read is okay, perfect. So like what we said we are going to reset parameter 2008. We set it to 10. Then it reset the drive to factory default. So what will happen is that we are going to do that right away. And then as we do that, try to look at the screen on my video. You can see the Sevodrive. You then try to see when I'm resetting, you will see the screen, the digital display responding to the command. And then we can power off and power on again, as we already explained. So let's go to parameter 2. You click here, parameter 2. We set parameter 2008. Parameter 2008. So now you can see the value I have here is 36. So we want to write it as 10 to reset it. Also, try to observe the video if there's a response from the digital display. You can see it's busy, done. I hope you saw that. So now it's 10. So we have successfully written. What I did, I wrote 10 on this parameter index. I just click enter. I could also double click and then also initiate the same stuff. But with the enter, the command has been sent to the drive. Now it has reset. So what I'm going to do now, I'll power off the drive and power it on again. Just as we have in our, if you look at this video, okay, I remove the USB because my USB is supplying 5 volts. So you can see now the drive is off. You can see. Then I plug my USB again. Let me power on the drive. Perfect. So you can see that I've successfully reset the drive to factory default, and you can see that alarm 13 is triggered, alarm 013. So what is the next step? We are going to set the control mode of the drive. That is parameter 1. We are going to use P arrow mode. Parameter 1, 001, we set it to 1. So let's go to our parameter editor. So before I start writing, I want to read the parameter to make sure that, though I'm off, you see I'm offline, let me go online. I want to make sure that I'm connected. So let's see if we can read. So then, yeah, we can successfully, it's reading. So we can read. Parameter read is okay. So now it means that I'm communicating, my drive is reachable. Now let's look at the other step. Parameter 1, 001, let's set it as 1. Okay. Parameter 1, 001, you can see it's 0. So I will set it as 1, backspace, 1, enter. So you can see I've written 1 to the drive. So what is the next step again? So now we are configuring the drive. For some of us here, I believe most of us here, we are experts. So please do bear with us. The way I'm proceeding, for you, it might be like, it's like child's play because you already know all this. But we also have some persons that are connected. This is their first time of getting to know about Servodrives. So if we go at a very fast pace, they might get lost. So just be patient. It will not take so much. This training is very straightforward. Be patient with those that are beginners so that they can follow the procedures. They can do it on their own when they get back to the factory. So the next parameter we're going to set the CANopen station address of the drive. So for this special function, take note of this. For this special function, the station address of the 8 Servodrive slave must be from 1 to 8. So if you are using just one Servodrive, like we have in this setup, as you could see in the video, the first Servodrive is 1. So you don't have to like, the function stipulates that you have to follow this address sequentially. So if you have 5 Servodrive slave, you need to use from 1 to 5. So that's why it's called special CANopen mode function. So when you do that, you can seamlessly control these devices. And later on, we are going to also see for the inverter as well. There's a specific station address for the inverter you have to start from. So let's go to parameter 0300. Let's set it as 1. So let's go to our parameter editor. Parameter 300. You can see now it's 7F. Let's set the CANopen station address to 1. I press enter. Okay. I've successfully written 1 to the drive, the CANopen station address. So what's the next step? So what we're going to do now, we're going to set the baud rate. So the baud rate is the speed, communication speed. That's parameter 03001. So let's choose 500 kilobits per second as the baud rate. So for that, we write this value 0203. Parameter 3, let's go to our editor. Parameter 301, this is the baud rate. So you can see it's 203 by default, so we can leave it at that. To be very sure, let's press enter. Okay, so now we have this at the baud rate. Then the next step is the digital function, digital input functions. You could see on the screen there is alarm. So by default, parameter 0211 to parameter 0213, by default, the digital input is normally closed. So that is why you see alarm 13. If you can see the video, you see alarm 13 on the screen. So to disable that, we change this 0 to 1. So now if we change it to 1, it means normally open. Now it's like the digital input is engaged. We have to disengage. So if we disengage by writing this, by writing 1, what is writing 1 here, writing 1, what is going to happen? The alarm will be cleared. So let's go to parameter 011 up to 13. Parameter 02 from 11 to 13. Then the alarm will be cleared. Parameter 2, 11. You can see, like what I was explaining, you can see there is 0 here. So this 0, it means it's normally closed. So that means the digital input is engaged. That's why you see the alarm. Then I will set this to 1. So now we have disengaged digital input. It's not normally open. And then for the other one, 12, parameter 12, let's also set this as well to 1. 1. This, let me make sure I've written, enter. Enter. And the last one, 13. So just watch the screen of the digital display of the drive. You see the error will be cleared after I have written this value. You see, it is cleared. Now you can see 0000. So the alarm that was there is all gone. Perfect. So now we are almost done with configuring the Sevodrive. So it's as easy as this. So what's the last step? We need to power off the Sevodrive. Then we'll power it on again. So let me remove my USB. My USB supply 5 volts so that I don't want it to have any power at all. Let's power off the drive. You can see the LED is gone. A few seconds. Then I power on the drive. So let me put my USB cable again. Perfect. So now the Sevodrive is ready to receive motion command from the PLC. That is all you have to do. It's as simple as this. Let's go to the next step. So the next step now, we're going to configure this other slave. That is the inverter. So for the inverter, First of all, let's also reset the parameter of the inverter. To do that, we'll go to parameter 0002, we set it to 9. So it resets all the parameters to factory default setting. So let's go to our editor. So I will open my DR Designer. So mind you, it's from DR Designer that I launch all the parameter editor. So in other words, all the parameter editors of the Sevodrive and the inverter is embedded in DR Designer. So I'm using one software to control all my devices. I'm not using several software, just only DR Designer I need to launch. So now let's go to the inverter. This is my DR Designer. So I want to check if it's connected. Let's go to communication settings. So my communication setting will open up. Once it opens up, I'm going to check the connection again if I'm connected. Yes, so I've launched. You can see now it's disconnected. This cancel signal, it means I'm not connected. My port of inverter is COM port 11, so it's correct. I want to connect. So if the connection is successful, you should see this blue, it will change to good symbol. This cancel, it will change to good symbol. Perfect. So I'm connected now to my inverter. Let's close this connection communication setting page. Now, if you come to the VFD function, this is DR Designer. Then you come to parameter settings. Let me close it. So this is my drive. There's internal PLC. I don't need that for this training. I'm going to the VFD function of the drive. I expand it. I come to hardware configuration. If I expand it, there's configuration. I come to parameter settings. In parameter settings, you can see this is drive 1. It has already opened the parameter setting page for us. So now I'm going to parameter 000002. See, parameter reset. We have to set it to 9. So let me see. Let me set it to 0 first. Then I set it to 9. Let's see if the value is written. So I want to download this download button, download the parameter. You can see it's written. You can see here the actual value now is 0, but what I actually need is 9. So let's just write 9 to reset. 9. 9. Then let's download. So you can download each parameter. You can download all parameters. So DR Designer has come to make configuring your machine very easy. So let's download this parameter now. So you should see actual value change to 9. Perfect. Change to 9. So according to the instruction we are following, now we have to reset the drive. So I need to power it off. So if you watch the video, you'll see the inverter display should go off. Let me turn it off for the reset to take place. You can see the display, digital display of the inverter is off. Now I turn it on, and we have successfully reset the drive. So we'll go to the next step. The next step now, we're going to set the communication protocol. So let us set the source of frequency and also the source, CANopen as frequency source. Also set CANopen as command source. So we'll do that with this parameter 020, 021. So let's set 020 to 6, and we set 021 to 3. So let's go. Parameter 00, index 20. Let's set it to 6. 6, enter. So it has been written. 21, 021. Let's set it to 3. I have 3 here. Let me download. I'll download. I don't know if you can see the display. Let me check on the display those parameters. Parameter 0020. Parameter 00 is 0. Let's go to 00. Let's go to 20. So I should have 6 here. Perfect, 6. If I go to 21, I should have 3. Perfect. So that's okay. So what's the next step? The next step, we have to set the digital input of the drive, MI3 as quick stop. To do that, we go to parameter 02, 03. We set it as 53. So I've connected a cable on this terminal, and I shorted the cable. So it's to help us for the quick stop of the drive in case of emergency. So parameter 02, 03, let's make it 53. 02, 03, parameter 2, 02, 03, digital input 3, 53. Let's 53 is there. Okay, before I write this 53, let us already see what is parameter 0203. Enter parameter 02, 03. You see, it's 1 because after we reset the drive, it becomes 1. Because it's an already open project, that's why you're saying 53. So now I need to write this 53. If I write, let's download the parameter. So it should 53. Now, if I look at this now, it should be 53. Enter 53. Perfect. So you see, we've successfully set MI3 for quick stop. And then we set the next parameter. So we are going at a fast pace. Before you know, we are going to start controlling these slaves, like like as you would think. So we are done with that. Now we are going to set the remaining parameter, communication parameter, parameter 0936. This is where we set the station address, CANopen station address. So for this special CANopen mode, just like we saw with a Sevodrive, for inverter, the station address must start from 21. So it's a special function. It is built in the firmware of these products. You have to start the station address, CANopen station address from 21. Since I have just one drive in this setup, as you could see in the video, I only have 21. So parameter 0936, we set it as 21. 0937, we set it as 1. That is CANopen baud rate, the speed. Let's do those two. 0936, we set it 21. 0937, we set it as 1. Let's go. There, designer 0936. Scroll down. So we are going to share this project with you at the end of the training. You can play with it. So 0936, station address 21. Let's write it. If I check it now, it should be a different value, but I'm going to write this. So I've downloaded the parameter. 37 should be 1. 1, write 1. I download the parameter. So I've downloaded the parameter. So I'm sure that the parameter now is written to the drive. Then we are going to parameter 0940. Let's see what that is. 0940 is the communication decoding method. So we are using DS402, and then we set this parameter to 1. 40, let's write 1. Download parameter, I've downloaded. So if you check now, it should be 1. And then what the other parameter we need to set? Yes, parameter 1133, CANopen as toggle mode. So if the drive supports toggle mode, if you set this parameter, then you can make the drive to operate in toggle mode. So let's just do it. We are not going to test this for this training. We are going to test the rest motion, possible motion that you can realize with this CANopen special mode function, but we are not going to test toggle. Let's set parameter 1133 to 3. Parameter 11, you have it here, 1133. Parameter 1133 to 3. I have 3 here. Let me write 3. Download. Perfect. So now we are almost through with the setup. So that is it. So we have configured the two slaves, the inverter, we are done. It's as simple as this. And you could also set the parameter just using the buttons on the drive, but I've done this using DI Designer because it makes life easy. With one software, I'm controlling all the devices that I'm using for this very machine. So what is the next step? The master, the PLC configuration. This is very easy. You just have to do two things and you are done. To start controlling the drive, we are going to control the drive shortly. So what do we do here? If you come to DI Designer, we are going to set just two parameters. CANopen port work mode, we select it as data special driver and AS. That's what we need to set. And then we set the baud rate. So the baud rate of CANopen baud rate of the PLC, which is the master, as 500K. So let's go to that. So now let me close this tree of the drive. We are through with the setting of the drive. Let me close the tree of the Servodrive. I'm done with the parameter setting. Now let's expand the PLC. So the PLC, so let me check the communication setting if I'm connected. So what I did, I used Ethernet to connect. Let me disconnect, connect again. Perfect, so I'm connected to my PLC with Ethernet. This is the IP address of the PLC. So now we are going to set the parameter. What you do, come to hardware configuration. Let me close all these that are expanded so that we could get it. So now come to hardware configuration, expand it. Then you have parameter setting. If you come to parameter setting, it opens up the page of that screen you saw in the PowerPoint. Let's open this. So we are there. There we want to set the built-in CANopen port. So because AS200, my PLC, has built-in CANopen ports. So we change just two things. If you CANopen work mode, you can see data special driver and AS remote mode. So CANopen special mode. I select this. It's ready. When I'm downloading, it should be downloaded. And then the baud rate, I'll set it at 500K. So this is ready. Sorry, 500K. At the time we are downloading, it should be downloaded. So now we are going to download this parameter. So I click my download. Let me compile first. Let's compile. So we are done with the setting. The next step we are going to now is just to test and see how easy it is to make your machine with this function. Let me download PC to device. So I will download the PLC parameter. I will not download. So this is download manager. It's possible to download everything in one go. So I don't want to download like the drive. I don't want to download the drive. For the Sevodrive, I don't want to download. So I want to only download the PLC. So the object code, all we have configured. So now if I click start transmission, the configuration should be downloaded to the PLC. So let's try it. It's downloading. So if everything goes well, it should change to success. That means we have successfully downloaded our configuration. Success, you can see, is downloaded successfully. Good. Now we are good to go. So this is the main part. You know, just like in coding, in machine making, coding is the last thing to be made. What the machine builder will do, they will first of all plan the architecture, plan the algorithm, and the last thing is the coding. And you can do the coding just in 1 week. And you can do the planning, the architecture in 3 months. So we have done the main thing. To not control the drive is just a piece of cake. It's not difficult. So now, what makes this special CANopen mode, how will I say, welcoming? What makes it very interesting? So what makes it interesting is that you can easily control your drive, your machine, using special application instruction, APIs. So now we're going to demonstrate. Just to be sure, let me check my baud rate for the inverter parameter 0937, if it's 500K, if it's 1. You can see this video, the camera parameter 09. I just want to be sure. 937 should be 1. For Sevodrive, I remember what that was. That one is correct. For this, I'm just skeptical. Perfect. So it's correct. All settings should be okay. Good. Now let's proceed. Sorry for going back. I just want to be sure our configuration was okay. Now, we have come to the business of the day. So this is the climax of this training. It's at this section. We'll be rounding up soon. And if you have questions, we are here to answer your question. Luckily, my colleague, Johan, is also on the platform to support us with questions regarding this function. So now, what makes it easy? What makes it easy for you to use this special CANopen mode is the application instructions that you can easily use to control your drive. So there's no limit to which height you can control your drive. So anything you want your drive to do, with this API, this command, you can ask your drives, they begin to do it. And those drives, you can use it for different type of machine. Packaging machine, milling machine, printing machine, depends on what the motion movement you are making, what you want to do in your machine. So the first steps, this is quite important. The first step to start controlling this drive, this slave, is to use this API. We call it initC, initialize CANopen communication. So once you initialize, if you execute this API, it will initialize the Servodrive and the inverter for CANopen communication. It means like it's sort of unchecking. The drive says, oh, I'm ready to receive command from the master. And the master knows, oh, my slave is there. I'm ready to command my slave. So that's the first step. You execute this, initialize the communication. And once you have done that, synchronously, what you could do also, we are going to the program shortly. This is what you are going to see. So we put this video here because we are going to share these slides with you also. You can watch this video. This is a video. You can watch this video when you get back to the factory. That's why we put it here. So after we have init, then initialize the communication. The next thing you have to do, you use this API as that on to enable the drives. So you can see S2, the operand S2, that is where what you write on this determine what you are asking the drive to do. For Sevodrive, if you write 0, the Sevodrive is disabled. But if you write 1, the Sevodrive is on. For the inverter, if you write 1, 0 is disabled. If you write 1, speed mode is enabled. If you write 2, you enable toggle mode if the drive supports toggle mode. And mind you, the S1, operand S1 is for the station address. So once you put the station address of these slaves on this operand, the command goes to that very slave that has the station address on this API. And then once the drives, they are enabled, so there's a feedback flag that tells you that, oh, yes, this drive has been enabled. So for Sevodrive, we have this feedback flag for the 8 slaves, if you have up to 8 slaves. So when it's on, the flag turns on. And for the inverter, if the inverter is enabled, this flag, that turns on. So it gives you a feedback that, yes, my drive is ready. So now let's demonstrate these 2 steps, initialize communication and also enable the drive. Let's go to our program. So let's come to DI Designer. Now we are through with the configuration. Now let me close the tree of configuration, programming, and then the main. Let's go to the main. So this is already made program. We pre-made this program already. So we are going to share this program with you at the end of this training. You can go through it sequentially to see what it offers. So step 0. So this program is like a state machine. So from state 0, we move to state 1. From state 1, we move to state 2, and just we go like a state machine sequentially. So this is the first step, step 0. We are waiting for the initialization of the communication. So once we initialize, once we trigger this contactor here, so the init is triggered. So initialize, this is the station address. That is for Sevodrive 1. So it initialize the Sevodrive, and if that is successful, the register, you can see the register for the Sevodrive, the flag will be on, telling us that yes, I'm ready for communication via CANopen. The same apply, the same init for the inverter. This is the flag, it applies. So when they are both initialized, we'll now move to the next step. So the next step, that is where we are going to use the ASDA on. You can see I already showed to us to enable. This is the station address of the Sevodrive, station address of the inverter. So now we are going to go online. I already have this program in the PLC to initialize this drive and also turn them on, enable them. Let's go online, dear designer, online. Now my PLC is already running, it's run. You can see we don't have any error, so it seems our configuration is quite okay. So now let's enable, let's trigger the init if it's true. So you watch this register. When the communication is ready, the register turns on. True. Perfect. You can see for both drive, they are both initialized for CANopen communication. And then our state machine has moved to state 1. And state 1, you can see this is state 1. This is where we enable the drive. So you can see I have a contactor here to enable both drive. This one will enable the station address 1, that is Sevodrive, and station address 21, that is our inverter. Now, if you see the shaft, if you look at the video, the shaft of my Sevodrive is still very flexible. I can move it with my hand. So the moment I enable the Sevodrive, the shaft becomes stiff. I cannot move it anymore. So let's enable the Sevodrive. True. Okay, let's see. Perfect. You can see the shaft is stiff. I cannot move the shaft. Sevodrive is enabled. You can see it's as easy as ABC. So you don't need any special degree. You don't need to make your machine to start running via CANopen with this special mode. Now it's enabled. So now let's enable the inverter as well. True. Yeah, the inverter is enabled. You can see the register, the flag, the feedback that both are enabled is here. So this is the step 1. We initialize the communication. Now we have enabled the drive. So the drive is ready to receive your motion command. And let's go back to our presentation. What else do we have to do again? The next thing we have to do, now that the drives they are on, we need to set the ramps. So we use this API, CASD, to set the ramp, the acceleration time, and the deceleration time. And then once this flag that we saw before, so it's also when we set the ramp, this flag should also give us a feedback that, okay, the command we have set to the drive is there. Look at the command, all I'm saying, this. So initialize for communication. So it means they are ready to communicate. So what is going to happen now? This is step 2. So from step 1, we have moved to step 2. So step 2, this is where the we set the ramps. So the ramp has been set now. And what we also did here is we set the homing. So we want to perform homing on the Sevodrive. So and the kind of homing that we choose is mode 4. That is homing on Z signal of motor encoder, OM4. So when that is ready, OM4 is ready, then we have come to step 2. Let's go back to our presentation. So now the RAMs is set. What is the RAM value in our program? The RAMs is for the Sevodrive 100 acceleration. For the inverter, you have 2000 acceleration and deceleration. So, and then for the homing method, we have choose mode 4. And then the drive is ready to use mode 4 method for the homing. So let's go back to the presentation. So now we are going to do the homing. We have already chosen homing mode as mode 4. So this is a video like I told you. So this is the homing command. So when this is triggered, it will move our drive to home. So once the homing is complete, this flag will be triggered that the homing is complete. So why is it important to home your drive? So it's important in your application because if you home your drive, it takes your drive to a reference point. So your drive goes to position 0 once the homing is successful. And then from that reference point, you can move to any place on your machine. Maybe you have a pick and place machine, you have a cutting machine. From the home, you can calculate the distance of the cutting, and from there, you know how far you need to move your drive to do the cutting. Maybe you are doing a pick and place unit, you know how far you need to move your drive to pick the item you want to pick. So the homing is very important. Move your Sevodrive to the reference point. So let's perform the homing. So check, can you see if you check the video, you can see that the data logo is not well positioned, it's vertical. So after I've done the homing, the data logo should be well positioned such that you can read it correctly. Let's see if that happens. Let's perform the homing. You can see there was a rotation. You can see the data logo now you can read it normally. Now my drive is home. So, and that is position 0. So from this reference point 0, you can move your drive to any displacement depending on the kind of machine you are making. So that is the first phase. And now we come to the let me say the climax of this testing. And then we'll give time for question and answer. So that is step 3. You can see that when the homing is complete successfully, we move our sequence to step 3. Now we are step 3. So what happens in step 3? In step 3, this is where we demonstrate the motion that you can make with this special CANopen mode. So one of the motion possibility is incremental position, incremental movement. So you move your drive incrementally to a position of your choice. For example, maybe your pick and place unit is 100,000 meter or millimeter displacement. If you specify that to the displacement on S2, where you want to move to, and then you specify the speed, the RPM, the target speed to move there. So it moves there. When it gets there, if it's a cutting application, if it's a pick and place unit, it picks what you are picking. So this is incremental positioning. So this is one of the position you can implement. So let's test it. Let's see how it works. This is one incremental position, and you use this API, DDROV incrementer. So your drive receives the command and increment the displacement or the position that you specify. So this is for the Sevodrive. So this is this instruction I just told you, DDROVIC. So now we are going to move increment. Now this is the position of my drive. My drive, the shaft, to see the video, is in position 0. Now I want to move the drive to position 100,000. And this is the speed it will take to move there, 60 RPM. So what happens is that if I trigger this switch, what will happen, this drive, the shaft will rotate, and then the value in my position from the home, it will move to 100,000. 100,000, depend on what, 100,000 millimeter, 100,000, it moved to 100,000. So that is the position in how will I say, in the displacement table. So depending on what you want in the distance, so it moves to that very position. And then you see here, the feedback, the current position will be 100,000. So let us try. I want to turn it on. Watch the shaft, the video. You will see it will rotate slightly to position 100,000. You can see it's moving. It has gotten there. And you see this flag is a feedback flag. This flag tells us that the motion command, the movement, incremental movement command has been initiated, is completed. And you can see this is the current position of my shaft is 100,000. So what will happen if I trigger this again? Can somebody tell me what will happen? Since I'm moving incremental, if I trigger this command again, what is going to happen to the current position of the drive? Can somebody, you can type, if you cannot talk, you can type it. And when you type it, we'll see your response, or you can talk. Just tell me, what will be the next position I'm moving to? Incremental. Okay, yeah, somebody is asking for the PPT and the test project after the webinar. Yes, we are going to share it with you. Thank you. My colleague has already answered. So I ask a question to Ross. If you cannot talk, you can type the answer to me. Let me see. Let's just think theoretically. So now I've moved incremental. This is incremental movement. If I trigger this command again, what will be the position of the drive? Which position will I move to incrementally? Any feedback? Answer. Oh, perfect. So we got a question and answer from one of our colleagues. It will increment 100,000. Perfect. That is the absolute answer. So if I trigger this command again, my drive will displace 100,000 more to move 100,000 more. Then the current position is going to be 200,000. So just watch this. What will happen here? And you watch the shaft is going to move. Thank you for the answer. True. A trigger. You see the drive is moving. Now it has stopped. Position 200,000. So it's incremental. So depending on the machine you are making that requires incremental movement, you can use this API. So you increment to the position of action of the machine. Depends on what you want the machine to do. Maybe move to position 200 and cut. When it gets there, you implement the machine start cutting, move to 200 and pick and place, it pick, it place. So this is incremental movement. So this is one of the motion command, one of the movement you can make when you are using CANopen in our ASPLC, especially with this CANopen special mode that makes controlling your drive with CANopen very easy. So you don't need to be an expert, you don't need to be a guru to use CANopen to move your drive if you use this special mode. So we have execute the first motion possibility, which is incremental movement. And let's go back to our presentation.
Victor, sorry.
Yeah.
I think one of the attendees has raised his hand.
Oh, okay. Please go ahead. Could you ask your question?
Hi, Fadi.
Yeah, okay. What will happen? You can type your question or you can talk if it's possible that you can talk.
You're mute, Fadi. In case you are trying to explain it, you're mute.
Myself? Can you hear me, Joan?
Yes, I can hear you, but I cannot hear Fadi.
Okay, good. Continue. Ask your question.
Okay, I was asking about your homing method. What is the origin? What was the origin?
To the origin, right?
Right.
Yes, if you home, it goes to the origin.
Okay, but what is the origin you selected before?
Okay. For example, if okay, continue.
I have a lot of echo. I don't know if you got the question, Victor.
No, I did not get it completely. Let me mute my mic. Maybe I don't know where the echo is from. Please, could you repeat your question?
My question. Okay. I'm asking about the homing method you selected. What was the homing method?
Okay, I select mode 4. That mode 4 of the homing is just to home the drive, to move the drive to the Z signal position. Look at the homing where it triggered the homing. Mode 4. So, you said?
Encoder signal.
Yes, exactly. So homing on Z signal of motor encoder. It's based on encoder signal. But
Okay.
yeah, Joanne, could you throw more light on that?
Yeah, it's
maybe.
If you move to the presentation, you have a table with the different homing method we have available on our servo drives. Here, I'm not sure if it's maybe too small to see it clearly. I don't know. Maybe you can do a zoom, Victor, or no? It's not possible. Maybe. Good. So we are doing the home method number 4, as you see here. It's homing in the forward direction and look for the seat pulse and regard it as the original point, so as homing.
Okay, thank you.
Okay, you're welcome.
Yeah, so the essence of homing is just to move your drive to a reference section where from that reference point, you can command the drive. And the type of application you are making could influence the choice of the homing method that you choose. So that's a good question. Thank you for that question. And then let's continue with the testing. So now we have already done the move incrementer. So with this move incrementer, you move the drive to the position you have specified. It always increments whenever you trigger the incrementer command. The next motion movement you can make is absolute positioning, absolute movement. And this is the instruction, DD arrow V absolute. And when the absolute motion is completed, this flag also gives you a feedback that the absolute movement has been initiated. So if we come to our software, let's test. So we already tested we have tested the move incrementer. Now let's test the move absolute, this API, absolute movement. So what happens is this, we are moving this is the station address, Sevodrive. We are moving the Sevodrive to absolute position to 200,000. And this is the speed, the RPM, 600 RPM to move to this positioning. So what will happen? You see, I already have 200,000. So let me move as incrementer from this position so that if we trigger this command, we can see what happens. So I want to move incrementer from this position. It should be 300,000. Let me move it once more again. You can see the shaft of my drive. It should be rotating. Now I'm position 400,000. Perfect. So now let's try the move absolute. So then what will happen? It should move my drive to the absolute position 200,000. So the current position of my drive is going to be 200,000. So if you watch this value, it will change to 200,000. So let's trigger this API through. The shaft is moving. You see now it's 200,000. So it's absolute. Absolute. So what happens is that if I trigger this command again true, you see nothing happens because it's already in the absolute position. So it will never move because it has gotten to that position that I want. So that's different. Incrementer will always move to increment to a new position that you have specified. But the absolute, when it is absolute, it means this is the position that is absolute. It will not move anymore. So what will happen now? You can see I'm in position 200,000. I want to move to position 0. Let's move absolute to position 0 with higher speed. So it goes much faster to this position 0. So you see the position of my drive now should change to 0. If I trigger this, move absolute to 0. Move drive 1, servo drive 1, station address 1, with this speed, 1200 RPM, to position 0. Let's trigger that. Let's see what happens. Watch my drive. You will see the shaft of my drive. And also watch the position on the screen where it goes to. At the end, it should be 0. Let's trigger. It's very fast because it was a very high speed. Now you see I'm absolute 0 position. So those are we have tested 2 possibilities: incremental movement, absolute movement. And now let's go to our slide. Let's test the other one. So the type of movement you use depends on the type of machine you are making, depend on what your machine is doing. So depending on your machine, you may need absolute movement or you may need incremental movement. So the other one we're going to try is the speed movement. Speed movement. Let's try that. So now we are here. Speed movement is DPLS velocity. Speed movement. So what are going to happen now is that I'm going to move my servo drive with this speed, RPM, 1500 RPM. So if I trigger this command, you should see this drive rotating in this speed continuously. So it will never stop. So if it goes to home, it starts again. It keeps on in a loop at this speed. So let's see how that happens. Watch my my drive is going to be running. If you can check the position, let me see. Okay, you can see the position is here. Now it's position 0. So I want to trigger the speed movement. True. You see, if you can see from the video, it's running. You can see my position is changing. So it keeps on moving. So it's like a circle. Once the circumference of the motion is completed, it starts again from 0. So it's a continuous movement. That is speed movement, speed. So now we have seen 3 possibilities: move incremental, move absolute, and speed movement. Perfect. You see it's running. What is the position? It keeps on. So once it has completed the possible position, it starts again from 0. So it's just a speed application. Your machine in your factory might need this kind of movement to continually move to turn something until you receive the stop command. So you could use this speed movement to control your machine. Now let's try to rotate with the same speed, but the opposite direction. Now I'm going to trigger this. Let's stop. You see, I stop. The drive has stopped moving. Now I want to go to the opposite direction, but the same speed movement. But then to rotate negative to the opposite direction of the rotation. Let's trigger true. You see, the same speed. It keeps on moving. Perfect. So that's servo drive. So let's leave the servo drive running. Let's go and choose the. Let's stop first. Let's go and choose the slow speed. Okay, it's 1.5. Okay, I will trigger this again, but then let's test the inverter. So the inverter, like you saw in our when I was doing the setup, there's only 2 motion you can make, 2 possible mode you can choose for this. If I go back, it's either speed mode or torque mode. It the drive support torque. You see, look at it. When you enable as that on, you see, if it's 1, which is we have selected speed mode, so the drive runs in speed mode. If the drive support torque and you enable torque mode, so it will run in torque mode. So for the inverter, the possible motion is only speed mode for now. Maybe in the future, it will be possible to do other precision movement like you have in the servo. But for now, you can only implement the velocity movement, the speed. So let's go to that. Let's test for the inverter. So if everything is okay, we should see our inverter running. So now the station address is 21. You see, it's the same thing we use for the Sevodrive, DP, LSVC, velocity movement, speed movement. This is for the station address of the inverter. So let's trigger this. You should see my inverter. It should be running using this RPM that is stipulated here. True. Perfect. You can see in the video, the inverter is running. So then let me run the opposite direction. I stop. I run in the opposite direction. You see, it's in the opposite direction. So let me trigger the Sevodrive to run speed mode as well. You watch my Sevodrive, should be running. So it's as easy as this. So if you have 16 drives in your machine, just with this simple instruction, you can command the movement of those slaves. Do you want to move incremental? They will respond to the command. Do you want move absolute? They will respond to the command. Do you want speed movement? So whatever command is coming from the master, using this API, your drive will start running. So you see, using CANopen special mode is ABC. It's a piece of cake. It makes controlling your machine with CANopen very, very easy. So we are going to go to question and answer section shortly. But before then, let me just run through a few other points that is important. The drive is making noise. Let us stop it first so that they will not make noise. Stop. Inverter is still running. Stop. Perfect. You see, it's as easy as this. You can connect this switch to your HMI. You can connect it to your SCADA. If you click the button, your drive does what you want to do. So it's as simple as that. Let's go to yes. So another advantage of this CANopen special mode, it gives you the possibility to send command to parameter register. So this, now we are through with the motion movement. So this is a add up. What can you do more with CANopen when you use CANopen special mode? If you use this API, this is called CANopen parameter read write. So with this API, you can read write parameter registers. So no matter what is parameter registers that you have in your drive, if it's a read only, you can only read. If it's a read and write register, you can read and write the register. And this API, application instruction, applies both to Sevodrive, applies both to your inverter. So how does it work? It's very simple. This is the operand of this API. You have S1, S2, S3, S4, S5. You can see it. S2 is request code. It's just like the function code if you are using Modbus communication. So request code means what do you want to write to your slave? If you write hexadecimal 23, it means you want to write 4-byte data to the slave. If you write 2B in the request code, hexadecimal 2B in the request code, it means you want to write 2 data bytes to your slave. If you write 2F, it means, so this is just the function code is kind of what are you sending to the drive? And then to read, if you use hexadecimal 40, then with this API, you can read the specified parameter group you want to read. And then let's come to this index and sub-index. This index, this is the parameter register. It's pointing to the parameter register you want to write. We are going to see shortly in our demo. So how do you reference the parameter you want to write or you want to read to in this operand? So this is how it works here. You see this X3 is illustrated here, PA-BC. So the parameter register always starts from 2. So 2 is constant, 2 would always be there. Then A is the parameter group. So for example, when we are setting the communication, we went pardon me to switch back to this setting. You see, when we are setting the CANopen for the inverter, we went in parameter group 9, and then we'll index 37 to set the baud rate. So if you want to use that CANopen read write, you specify the parameter group and you specify the index you want to write. So let's go and see from that illustration how you interpret that. So A is parameter group. So in our case, where I just showed to you is group 9. So if I was going to write that with this API, there should be 9. And then BC, that was 36 or 37. So BC is the index. So what happens is that for you to have the correct index register to specify, you need to convert the BC to hexadecimal format. So it's in decimal, you convert it to hexadecimal format. Let's test it on our project and see how it works. So now if you come to this step 3, so we want to, now we are in step 3, we want to write parameter 1088. We want to use this API. So parameter 1088. So this is parameter group 1. So it means that this is the sub-index. 2 is always there. So this 1 would always remain. You see, this is the sub-index. It is 1, 2, 1. So this 1 is the parameter group. In the configuration we made earlier for the settings, if I was writing the communication parameter, this 1 would be 9. But in this example, we want to write parameter 1. So that is why this 1 must be 1. 2 is constant for all. That is where the parameter registers starts from 2000. And then this 58, how do I get this 58? So to get this 58, this 88 is in decimal. I've converted this 88 to hexadecimal to be 58. The way I normally do that, calculator, you can use my calculator. If you open your calculator, you can, on your PC, you can select programmer. If you select, let me clear everything I have here, programmer, and I have decimal 88. Double click decimal. So if I write 88, in hexadecimal, I will get the equivalent of that 88. And you will see it's going to be 58. So let's try decimal 88. You see, I have 58. So this is how to convert it. So what happens? You write 2 is always constant, be 1. Is it parameter 9, group 9? It should be 9. But now in this case, parameter 1, we put 1. And then this index, the real parameter you want to write, and this parameter is togg ohmI level reach timer in Sevodrive is 88. So I convert this 88 to hexadecimal. That's why I have 58 here. So with this API, what am I doing? I'm using 2B. Like you saw, 2B is 2 bytes. This H2, this is the request code. It's like the function code. 2B, I want to write 2 bytes to this index, to this parameter. And then this is the sub-index. So this parameter is just one parameter. It doesn't have sub-index. So this is always 0. If you use this API, it's always 0. Then you write the parameter register. So now what are we going to do here? I want to write this 77 to this parameter 188 in the drive. So let's see, why is this 77? You may ask. When we initialized this project, we wrote 77 at the beginning. This is network 8. We'll be through in 7 minutes. We're through with everything. Then you can ask your question. So you see, when we started the program, we initialized the program, and then we send 77 to this variable. That is why you see 77 in network 8. Let's go to network 8. I'm there. So that's why you see this 77. So we could change later. Then, I don't know if you can see my display. The display, let me go to this parameter 188. Let's see what's the value that is there before we trigger this command. Let's go to mode, parameter 1, now group 1, index 88. I want to write parameter 88. So I'm moving. So now I want to check if you, I don't know if you can see my screen, maybe it's so small. Let's check. Good. So now in this parameter, no, I shifted. I think, let's go back, parameter 188. We can also read it with their designer, but let's read it with this one first. Maybe before we close, we can check what is the value in their designer. But let me go to parameter 88. So now I'm almost there, 88, perfect. If you could see, maybe the video is so small, you could see 88, probably. Parameter 188. Let's see what is inside. I press set. So I have 2000 inside, perfect. I have 2000. Now, I want to write, I'm going to write 77 to this parameter with this API. Let's trigger it. Let's see what happens. Now, if I check this later, you're going to see it's going to be, let's write 11111. No, 777. Let me trigger true. So now I write in what I'm doing on this network, I write and read. So now let me go to this parameter again. Mode, parameter 188. Enter. You see, I have 777. Perfect. So let me change this to something different. Let me say 44. 444. 444. 444. I press enter. 444. Sorry. 444. Enter. So now it's 444. Enter. I want to trigger it. I want to write it to the drive. True. You see, I will read it 444. And let me check the drive. Mode is 188. Set. You see, it's 444. And the same thing also, if our parameter editor is connected, the same should also apply. If I read the parameter, I go online, you should see 444. Parameter 188. If you scroll down to 88, index 88, 88 is down below. Parameter 188. So let us read. If we read the drive parameter, it should give us 444. Parameter read is okay. Parameter 1. Let's go back again. 88. What do we have? Perfect. We have 444. You see how easy it is to send command to your parameter register using this API, CANopen read write. So let's go. So that's what we have just initiated. Once the parameter register can be read, you can use this API to read it. If it can be written, you can use this API to write it. So this is how easy it is. So you don't need to know CANopen. You don't need to be a CANopen specialist to send CANopen command. Just execute this API. Your slaves, your drive will receive the command right away. So that's for that. Let's check our presentation. Okay, good. So another one again, we are not going to test this. This is similar. What happens is that with this, you can write groups of data. The first one which we saw, you only can write one parameter register. But with this, you can write group parameter register. So if you use this API, corp WL, you can specify multiple parameter you want to write. Then it supports 16 bits, this is for 32 bits. Good. Last but not the least is the NMT protocol, slave service protocol. So with this protocol, you can send some specific message to your slaves, to your drive, to manage the network. So one of the messages you can set is the reset. You can send the reset message. So if you send this reset message with this API, then it goes to the slave. So then also, that's for that. What will happen to test this? I will not test this. I will just explain to you how it will work. For example, if I remove the CANopen cable, you can see my drive. If I remove the CANopen cable from this network, if I remove the CANopen cable, there's going to be an error. So when the error is triggered, if you want us to test, write on the chat, say test, then I can test it. When the error is triggered, to clear the error, to go back to step 4 to make the machine to run again, I will just trigger this switch, and then it will trigger this reset command. This reset command, it will reset the drive. So this is based on SDO. No, it's based on NMT. So you are setting some service management message to the slave. So this RSTD, it will reset the drive and the network will be normal. So once I connect the cable again, you see the error will be gone, I have to reset, and everything will be okay. And finally, like I told us, in addition, there are some special registers and flags you could use as feedback in your machine. So this is very handy. If you need to get some feedback, what is happening, there's a lot of CANopen registers that you can use. So like, for example, for slave 1, slave 2, slave 3, slave 4, is the servo on? Is this drive enabled? Then you can read the status of this flag. And beside this, there are other parameters indication, what you would like to know about the network, about your drive. So depending on the need of your machine, you can use one of these special registers. So it's like a feedback to know what is happening in the machine. So there is quite a lot. So that is all we have for today. So you will receive this presentation. You can go through this and make choice of what you will need. This is also for the inverter from station address 21. You have special register to monitor the status, what is happening in the network, what is happening to the drive. So it's like a feedback loop system on what is happening on your machine. So that is all we have for today. It's a special register. So thank you for your patience. Thank you for waiting to the end. We so much appreciate you. Now we'll now give room for question and answers. If you have question, please, you can kindly ask your question. You can type your question. You can answer it verbally. You can ask it verbally. If you have the possibility to talk, you unmute your mic and then you ask your question. So we will share this presentation with you. Also the project we have used, we share it with you. And then also if this video has been edited, if there is no issues, we could also publish it on YouTube, and then we could follow it later. We can share it with our new customers that want to know how to use this mode. Do we have any question? If no question, I think my colleague, I will just invite my colleague Joanne to say 1 or 2 words.
I think, sorry, Victor, I think Fedi has something to ask.
Okay.
But you're mute, Fedi. We cannot hear you.
No, but I was asking if you will publish the presentation, your presentation. I got the answer.
Oh, the presentation, right? Okay. You have got the answer. Yes, we are going to share it with you. We share the presentation with you. We share the project with you, the GI Designer project. I hope if you don't have GI Designer, you can download it from our website. It's free. And then you can go through the steps of what we have made already. Yes. So that was it. Please just hold on. When this meeting is ended, you will receive a survey. We plead your indulgence to fill the survey. Be very candid, be sincere. It's anonymous, so we don't know who has filled the surveys. So that will help us to improve this training. So I will just invite my colleague Joanne. Maybe he has 1 or 2 things to tell us, and then we can end this meeting if there's no other question. Joanne, please.
Yeah.
You can on your video.
Thanks, Victor.
Yeah.
I just want to thank you all for assisting to this training. And just to let you know that we are we will help you whenever you have any question or any help you need from our help. We will be eager to help you on that. So that's all from my side. I think most probably you will receive presentation and project by tomorrow, not today, but not later than tomorrow. That's all from my side. Thank you again to all of you.
Okay, thank you all for connecting. Thank you for joining. We'll now end the meeting. You'll get a survey. So please just fill the survey, and then we are so happy. So have a nice day. So bye, everyone. Thank you, Joanne.
Thank you. Thank you. You're welcome. Bye.